Hello everyone, welcome to KCD Bangalore 2022. Today we are going to talk about Unleash CI/CD with Tekton and ArgoCD. Little bit about ourselves. Myself Savita, I'm working at Red Hat and meet my colleague Shivam. He's also working at Red Hat and we both are contributing to Tekton project. And you can find us on these below details. Moving on, so this is the pretty much agenda we have it for today. We are planning to cover Tekton overview, its core concepts, then ArgoCD overview, and finally a live demo on building and deploying news application in a dev and stage cluster using Tekton and ArgoCD. So let's talk and understand about the overview about Tekton. Tekton is a Kubernetes-based CI/CD framework which is open source project. It was initially started by Google, Red Hat, Pivotal, and many other companies, and now it is part of CD Foundation. Tekton is basically used by developers who try to do CI/CD in their application development day to day, and also used by platform engineers who develop CI/CD system for their developers in their organization. Tekton is a very big project. It has multiple sub projects which does a different operations based on the different use cases. And today we are going to focus one of the two major sub projects of Tekton are pipelines and triggers. Let's understand about the Tekton pipelines. So this is one of the sub project of Tekton CD. It has its own core resources, something which is similar to like how we have in Kubernetes, like deployment, pod, services. The resources in Tekton pipelines are step task pipeline, task run pipeline run, and results. Let's understand these resources, working functionality, and how they interact with each other. So I have a scenario where I'm planning to clone the code, build the image, push it to the registry, and deploy it to the cluster. So this is just an end-to-end CI/CD from source code to the deployment. So to do this operation, I can use Jenkins, but I want to do it using the Tekton pipelines concepts. So let's take one of the very basic object of Tekton pipeline is step. A step is a custom resource which is very similar to container and which does some operation based on the provided information. So as I said, like I will be cloning, building image, pushing and deploying. So these are the multiple stages of operations I have. So I'm writing a step to clone the code, writing a step to build the image, push the image, get the digest, and finally deploy it on the cluster. Now, these steps are like an individual container. So here there is only one that is okay, but when it have multiple such steps, then how do we handle the communication between those? So to provide such functionality, Tekton pipeline have another custom resource called task. So task is basically a custom resource which contains multiple steps and also try to execute those steps in a sequential order. And the output of one task can be given as input to the other task. The input-output handling of thing is done in pipeline using a custom resource called pipeline resources and results. So this task is basically a static template which will, when we create the task custom resource on Kubernetes cluster, it will just apply, or we can say create it. It doesn't execute any of these steps. And if you want to execute those tasks and the steps inside those tasks, we have another custom resource called task run. So basically task run is a runtime entity which instantiates these tasks. Now I am doing this source code thing like cloning and deploying. Let's suppose I have done for Go. But similarly, I want to do for other project of Java, other project of Python. So for all those things, I have to execute multiple times of this task, multiple times of this task run, which is kind of a tedious job because I'm just repeating every time. So instead of that, let's create a one big template which can combine all these tasks together, and with single uh, runtime unit, it should execute everything. So to do that, we have another custom resource called pipeline. Pipeline is a static template which contains multiple tasks, and also pipeline controls which task to be executed when. And to run this pipeline template, we have a runtime entity which we call as a pipeline run. This is another custom resource provided by Tekton Pipelines. So till now, I have written a step YAML, I have written a task YAML, I have written a pipeline YAML, and to run this pipeline, I have wrote pipeline run YAML, or I could have done through CLI, but everything I have done manually. So writing pipeline is something anyone can do, but executing that pipeline should be something automated. We cannot manually handle running of the pipeline every time whenever it is required. So to achieve that thing, to make sure that, as we know that CI/CD is used for automation. So if we do stuff manually, that doesn't give any value for the CI/CD concept. So that's the reason Tekton CD come up have a another project called Tekton Trigger. So Tekton Trigger is basically a sub project which its motive is to execute the Tekton pipeline resources dynamically based on some event. Even this Tekton Trigger also have some of the resources, its own resources like event listener, trigger, interceptor, trigger template, binding, and cluster trigger binding. Let's understand each of these resources diagrammatically. So let's suppose I have every pipeline setup, everything is ready. Now I want to execute my pipeline based on some event. So let's suppose I want to take event from the GitHub, right? So let's suppose I have written I have a Go application where I have configured a webhook. So whenever I send a push request, pull request, any of the request, as I have configured webhook, so that event comes to this event listener object. So it means in my cluster, I have created event listener object which watching the event coming from the GitHub repo. So that's the reason whenever an event comes to the event listener pod, it does some operation. So basically this event listener pod is a HTTP or it could be an HTTPS server which continuously watches the incoming event coming from the GitHub, or it could be GitLab, Bitbucket, any of the sources. So once event occurs, it passes to the trigger. So trigger is a custom resource which basically thinks what to do with the event. And then it makes use of the cluster interceptor, which actually does the payload validation, secret validation, and some other processing part. So once all those things are success, it passes to the trigger binding, which is another custom resource. It will do some modification to the input data, or you can say payload. Once that is done, it will pass that information to trigger template. So the trigger template is a custom resource. It is just like a blueprint which actually contains the pipeline run or task run. And at the end, it will just go and create those Tekton resources. So this is how Tekton trigger work. And maybe like at the end in a live demo, if time permits, we will show how this trigger template looks like and how we will encapsulate the pipeline run or task run inside the trigger template. So this is about the Tekton triggers. Now moving on to another very big project of ArgoCD. So for the time constraint, I am not going in depth about the ArgoCD. Instead, I am just giving high level overview of Argo. So ArgoCD is a declarative and continuous delivery tool for Kubernetes. And also, it can be run as a standalone or it can be combined with a CI/CD workflow. And the source of truth for the Argo is a Git repository. And basically, Argo is used as an automation tool for the application management, application lifecycle. Similar to the Tekton, Argo also have number of concepts, number of modules and resources. But today I'm just taking one resource that we are using in our demo, which is application. Application is a custom resource which actually contains the information of the Kubernetes resource. So as shown in the diagram, you can see that kind application is a custom resource which contains the information of source. So basically, this source contains the path. What is this path is nothing but it's a directory inside this repo, github.com Tekton CD ArgoCD. Inside this repo, there will be a directory called create stage, and inside this directory, Kubernetes resource exists. So I mean to say Kubernetes resource is deployment YAML, service YAML, ingress if there are any. So this will be deployed in the Argo CD cluster. Now I will be talking about another concept which is sync. Sync is kind of a process which try to make sure that the application on the cluster is in sync with the resources or resource object which are exist in the Git repository. So this is the functionality of the sync. That's all from the Argo CD which we are planning to cover as part of this talk. Now I'll quickly start for the demo. So in the demo part, what we are going to see is how I'll just explain the high level overview of the demo which we are planning to do. So we are planning to build and deploy news application. So for that, we have two repositories. One is the application repository and one is the config. So this application repository contains the business logic and config contains the YAMLs. And I will have two clusters, dev and stage cluster. Dev cluster has installation of Tekton, and on stage cluster we have installed a Argo. So whenever user merge pull request on this application repository, as we have configured a webhook, so whenever a merge pull request occur, it sends an event to Tekton triggers, and based on the event, it tries to execute the pipeline. This pipeline contains multiple tasks. Those tasks are cloning the code, building the image, deploying it to the dev cluster. Once the deployment is success, then it will send a pull request to this config repository with the changed image information. So before we go and merge the pull request from the config repository, let's try to make sure that the deployed application is working perfectly on dev cluster. So now if it is working success, let's go to config repository, merge the pull request. So once we merge the pull request, we see that the application which was deployed on the stage cluster have different image compared to the image which present in this config repository. Now here a sync concept arrives and it tries to make sure that the images present in the config repository and on the stage cluster are same, and then it will take that latest image and try to deploy automatically. So this is how Argo works with the help of sync and application CR. So till now we see the high level overview of application which we are going to demo. Now I would like Shivam to take over from here and start showing the live use cases of these. Over to you, Shivam. Thank you.
Yeah, thank you, Savita. So I will be taking over the demo part. So as Savita discussed the architecture of the demo, so we have two clusters. One is the dev, another is staging. We have Tekton installed on the dev cluster and ArgoCD on the staging part. And we have two code repository. One is for the application code, where is all the logic remains for the application, and another is for configuration. We can also maintain just one repo, but for the demo, we have maintained two separate, one for code and one for configuration. So we will be doing some code changes, then looking like how the pipeline is started, how it will deploy the update the dev instance, and then creating a pull request to config repo, and then how ArgoCD updates the staging instance. So for the due to time limitation, so we have installed all the required Tekton and ArgoCD on the clusters, and also deployed the application. So in this repo, you will find all the documentation, like for the installation, for the demo, and you can also perform this using a single cluster, and if just like in a different namespace, two different namespaces. But we are targeting a scenario where we have two different clusters. One is the dev and another is staging. Okay, so let's start. Before we do some code changes, I just want to show you a demo. So this is a simple news demo application where we can search for news, and it's just simple. Okay, so we have one dev instance, and we have another staging instance which is on a different cluster. Okay, so now we can just go to code. So this is like the news demo code repo, and we are just going to do one change. So we are going to update this title here with news demo to news demo by Tekton and ArgoCD. So I'm just going to do some replace here, and I'm just going to commit that change, and just say updated title, and once I commit it, I'm going to push it. Okay, so once this is changed, so we have two clusters, right? One is we can access staging here and dev here. So I'm just going to see whether the pipeline is started or not. And if I do give get pipeline, we can see that pipeline is started. So this is the CLI view. If we also have a Tekton dashboard, which is provided by Tekton ArgoCD, and here we can see all the Tekton resources. So we have one pipeline installed, and for the event which just we triggered, that the push event, a new pipeline run has started. So here we can see the pipeline run. It is like we have different tasks, right? So we have cloning, we are building the image and pushing to a image registry. Then we are updating our dev instance with the new image, with the new changes, and then we are creating a pull request. So we will see in a bit. So till this happens, let's see the different components which we perform for this demo. So if we go here, so we did some code changes where we pushed a new commit, right? So a new event has occurred. So there is an event listener on the cluster. That is the Tekton event listener. So if I go to the dev, and if I do kubectl get event listener, so there is an event listener which is configured, which is listening for the event. So I have created an ingress for this, and using that ingress, I have configured a webhook. So if we go in our code repo and in the settings in the webhook, we can see this is the ingress for that event listener. So whenever an event occurs, GitHub will send the event on that event listener. So the event listener will process the event, and as Savita explained our different concept of triggers like trigger template and trigger binding, which we have here, which are already applied on the cluster. So trigger binding is nothing but we are fetching some of the data from the payload. So we want commit ID, the URL of the repo from which the event is coming, and the push at, like when the time is pushed at. And we are using that in our trigger template. Trigger template is nothing but where we define our pipeline run. So the push event occurs, the event goes to event listener. The event listener will use this template to create our pipeline run. So here we have defined our pipeline run and given some configurations to which the pipeline will be started. And if we go back to our Tekton dashboard, we can see the pipeline is completed. So in the last task, we can see a pull request is created, right? So I will just open this. We will just go here in a minute. So we have different tasks we have used. So most of these tasks are reused, like we have used it from the Tekton Hub. So you will find here in different tasks which you can reuse based on your requirement of your project. There is one task which we have wrote specifically for our use case, which you will find this in this code, this repo. And now that we have created a pull request, so this is like a change in image for our staging instance. But before we want to update the image for the staging instance, let's just go to our dev and like test our changes whether it is successful or not. So now we can see the title is changed, right? And this is our dev instance. So, and if we go to our staging instance, there is no change, right? We haven't applied any changes there. So we are okay. Once we are okay with the changes, we will just go to our pull request and we will merge it. So what this will do, this will update the image in our repo, right? So these are the app manifests, right? So ArgoCD, we have configured ArgoCD to watch our application in this directory for this repo. So how that is created? So there are multiple ways to configure application. One is from the ArgoCD dashboard. We will come here in a minute. And another way is using YAML. So we created an application YAML where we told the ArgoCD that this is my repo, this is the directory which you need to watch, and you need to maintain the resources on the cluster. So now we can. So once we applied the application CR on the cluster, ArgoCD will create all the resources on the cluster and will show us in the dashboard. So if we refresh here, okay, now we did some changes in the repo, right? And now ArgoCD says this is out of sync. That because in the repo the image is changed, right? When we merge the pull request, the image is updated. And now Argo is saying, do you want to update the image? Basically the deployment. It says that this is out of sync. So there are two ways. One is manual sync, or you can also configure as automatic sync. So currently we have manual sync. So I will just do a sync here, and Argo will fetch the latest deployment and update it on the cluster. So now we can see this is sync, right? So if I go to the staging cluster, if I do kubectl get pod, and we can see the image is pod is recently started, right? 70 seconds. Now if we go to our staging instance, which was not updated previously, now you can see, yeah, this is updated, and this is our staging instance. So this is how we automated the things. Some of the steps are manual and some are automated. So if you see here, just to recap, we did some code changes. We had an event listener listening for the events, which started a Tekton pipeline, which cloned the code, built the image and pushed it to the image registry, updated our dev instance, and then created a pull request. So before merging the pull request, we tested our changes on the dev instance. The changes were fine. We are okay with the changes. Then we merged the changes in the repo, and ArgoCD was looking for the update. It figured out that there is something changed, and it was showing that out of sync. So we went and we said, yeah, you can sync now because we are happy with the changes, and it updated the changes on the staging instance. So this is how you can use Tekton and ArgoCD together to make your development and deployment quite easy and synchronized. And you will find all the information, the explanations, and the installation steps in this repo. That is Tekton-ArgoCD. And if you can just try it out, you can just try it on one cluster. It is not required to have two clusters. You can just install Tekton and ArgoCD on the same cluster and try it out. So you will have just two instances in different namespaces, and that would also work. So if you get any issues, feel free to create an issue here, and we will just help you out. And yeah, let us know your feedback here also. That's all from the demo. Thank you for watching.